Hello and welcome to notes number 2, the substitution method. Today we're going to take a look at another way to solve a system of equations instead of graphing. We've seen in class that sometimes graphing isn't convenient. The numbers might be very, very large, or the solution might not be a whole number that's difficult to read from a graph. So today we're going to take a look at an algebraic method. So here we have a system. In our first example, 3x minus 2y equals 11, and x equals 9 minus 2y. We have a system here. Now instead of graphing it, what I'm going to do is step 1 here. It says isolate a variable in one of the equations. So that means in one of the equations, I want to get one of the variables by itself. It doesn't matter which one. Now in the first equation I see it's 3x minus 2y. Neither of those variables is alone. But in the second equation, I see that it says x equals 9 minus 2y. So in that equation, x is already isolated. X equals 9 minus 2y. It's already done for me, so that's the one I'm going to choose. Now the next step is, once that one of the variables is isolated, I'm going to take that expression and substitute it in place of x in the other equation. Because this says that 9 minus 2y is equal to x. So I'm going to take this expression and substitute it in place of x in the other equation. So the way it's going to look is the other equation says 3 times what? 9 minus 2y. So I'm going to substitute this expression instead of x, and then continue writing the rest of the equation. Minus 2y equals 11. Now the purpose of that is now I have one equation only, and I only have y's. This I know how to solve. So now that I have this situation, I can just go ahead and solve it. So for step 3, we're going to solve this equation, and we can just distribute the 3 to both terms and get 27 minus 6y minus 2y equals 11. And then we're going to combine like terms here. 27 minus 8y equals 11. Now we're going to get y by itself, so we're going to subtract 27 from both sides. And when we do that, we have negative 8y equals negative 16. Now the last step is to divide both sides by negative 8. So we have y equals positive 2. So now we know what the y variable is. So when those two lines intersect, y will be 2. So to find the x variable, all we have to do is substitute 2 into either equation. So I'm going to pick one of the equations, it doesn't matter. I'm going to pick the one that says x equals 9 minus 2y, because I think it'll be simpler. I'm going to substitute 2 in place of y. So I'm going to have x equals 9 minus 2 times 2. Well, 2 times 2 is 4, so x equals 9 minus 4. 9 minus 4 is 5. So that's my answer. X equals 5, y equals 2. So I can write it as a coordinate, 5, 2, or I can write it x equals 5, y equals 2. Either way is acceptable. So now I know that the point that both lines have in common is 5, 2. Okay, now that we know that the solution is 5, 2, we're going to check that solution in both equations. Because if that truly is the solution, that means 5, 2 will work in both equations, in both 3x minus 2y equals 11 and x equals 9 minus 2y, meaning that it'll make both equations true. So what I'm going to do is write the original equation here, 3x minus 2y equals 11. And then I'm going to substitute in the value 5 in for x and 2 in for y to see if it works. So I substituted 5 in place of x and 2 in place of y, and now I'm going to evaluate this. 15 minus 4 equals 11. And again, this is still in question. I'm working vertically. So now I do this. 15 minus 4 is 11. So I see that the left side equals the right side. So I know that it does work in this equation. This worked well. Now I'm going to try it in the other equation. So I'm going to write here x equals 9 minus 2y. And I'm going to substitute in 5 in place of x and 2 in place of y to see if it works. So 5 equals, and again, this is going to be a question mark because I'm not sure if it equals. I'm going to check that. 9 minus 2 times 2. Well, this is going to be 9 minus 4. 2 times 2 is 4. And 9 minus 4 is 5. So I see here again, this did work out. The left side equals the right side, so I know we did it correctly. So to summarize, the way we found this is that we isolated one variable, substituted it in place of that variable in the other equation, and then we solved. So let's try that in another example. Let's try one more example. Here we have a system of equation, y equals 3x minus 7, y equals 2x minus 5. Now, when I see this, I see that both variables are solved for y. So here, this is already y by itself. So is this one. So since this is set equal to y, I can take this expression and substitute it in place of y in the other equation. So when I go to write this, instead of y, I'm going to write 3x minus 7 is equal to, because here it says y is equal to, 2x minus 5. Okay? And then I'm going to go ahead and solve this. I only have x's here, so I can subtract 2x from both sides. I can solve for x, and then I can find my value of y. Okay? Same thing in the second example. In number 2, here, this is not, x is not by itself, nor is y, but in the second equation, I see x is by itself. It's isolated. So I can take this expression and substitute it in place of x in the first equation. So instead of x, I can write 9 minus 3y plus y equals 1. So what I'd like you to do is finish these 4 examples. You're going to check number 4 when you get to it. If you have any questions, write your questions down in the margin so you remember to ask me, and then we can talk about it in class tomorrow. Thank you very much.